Space. Could it be the final frontier for your data?
And we have liftoff. Hi, I'm Angie Lau, Editor-in-Chief of Forkast Labs, and we're here in Davos, and we really have liftoff. Last year, we reported on Filecoin Foundation partnership with Lockheed Martin, creating nodes in space, but now we're learning about the mission firsthand with Marta Belcher. She's president of Filecoin Foundation, but this partnership actually was born in Davos, right?
It absolutely was. So back in May, you were here and you heard us announce, Lockheed Martin and Filecoin Foundation announced back in May that we were working together to figure out how to put the Interplanetary File System, IPFS, into space. And we are so excited to be back in Davos, and we are actually announcing the specific details of the mission.
All right, do tell.
All right, so the specific details of our mission in 2023, we are actually going to be launching on the LM-400 spacecraft, which is a Lockheed tech demonstrator spacecraft. And what we're going to be doing is actually demonstrating how IPFS can actually speed up communications across long distances in space. And so the way that this works is, IPFS was actually always really envisioned to be a technology that could enable long distance networking. That's why it's called the Interplanetary File System. It's actually made for space. And the reason that it works is that, if you have today's centralized internet model and you try to use it in space, it's so slow, it just doesn't work. Because today's internet model works by basically saying every time you retrieve data, you take it from a particular place, a particular server. So if you have to go back and forth from Earth every time you retrieve data, if you're on the moon, that's a multi-second delay. If you're on Mars, that's a multi-minute delay. And every time you retrieve data, it has to take that exact same path, and there's a huge delay. And with IPFS, what we do is we actually retrieve content by what it is, rather than by where it is. So it can retrieve it from wherever's closest. And so if there's a satellite going by, if you're on a lunar station and it's already been downloaded, it will come from there. So it eliminates the delay. And so we are so excited to be working with Lockheed Martin to really demonstrate how this technology can work in space and how this technology really speeds up the communications. And so we're thrilled. So our first mission, we're going to be having software on the LM-400 spacecraft. We're also going to have software on a ground station back on Earth, and we're actually going to be using the software on this satellite to basically process sensor data that will be coming in from space, so sensor data from space, and we're going to process that information in space and send it in chunks back to Earth, have it be processed again down on Earth, and then we're going to emit it out to the entire IPFS network. So anyone can actually download and use that data set, that sensor data that came from space on the IPFS network. And that is how this demonstration works.
And the incredible, almost national security aspect of being able to do that at the speed of immediacy in real time is so important as well. You've technically removed one of the biggest bottlenecks that we face on terrestrial Earth right now, which is if there is a centralized location where all of this is stored and that goes down, we kind of all experienced what a massive meltdown of, in Slack, in Google. We've experienced these things already, these massive network failures. Could this prevent that in the future?
Yeah, absolutely. So one of the other major benefits of using IPFS in space is that basically, on today's internet, you really are looking for data in a particular location. And if it's not on that server anymore, which happens all the time for all sorts of reasons, then you can't retrieve that data. But what happens is, if you actually retrieve it by what it is, then it'll just take it from wherever is closest. And if it's not there, it'll just go to the next closest place. So it really makes it so that your data isn't dependent on any one server or company to stay up. So this is really important when you have, just one example from space is if you have radiation that's messing with data, right? That you can actually get if the data is corrupted, you can get the data from somewhere else. So that's another great example. The other thing from, as you mentioned, really interesting use case here is that not only are you able to download data from space using the IPFS network, what you're able to do is cryptographically verify that that data has never been tampered with.
Wow.
So you can cryptographically verify that that space data is actually the data. And so, when you're talking about sensor data, that's one thing, but maybe you're also talking about satellite data, satellite images, for example, right? So you can imagine really the use cases of being able to take satellite images from space and transmit them back to Earth in a way that is cryptographically verifiable that it has not been tampered with.
To the moon and back. You've made it happen. Marta, thank you.
Thanks, Angie.
Alright, that's it from us. Do like and subscribe to this video for more content like it, and let us know your thoughts on what's happening in the comments or wherever it is you're watching this video.